Okay, right, so again, a Friday afternoon, and we're doing the professional programming course. Okay, so last week you guys noticed that I had problems creating my library. Yes, this was annoying. And I got to the DLL, some reason the 140_app DLL wasn't working. So I was trying to fix that, and my decision was, why don't I just install 2017, Visual Studio 2017, like it keeps telling me to do at the top of every page that I go to. Oh, you should be doing this in 2017. So I do the same process in 2017, and yes, it works there. So it does appear that I did most of the things that I needed to correctly. It was just that I have a broken 2015 install. However, what I did is, having gone through that, I had a look at a couple of the other ways that you do Visual Studio. You can do test cases and build DLLs in Visual Studio. Now, there is a writing a unit test page, this page here, and I'll just copy that to the Firefox page so that our externals can see that as well, and make sure I'm actually interesting. Every time I do that, it turns that off. There we go. So writing unit tests for C and C++ with Microsoft Unit Testing Framework for C++, right? So what you guys saw me do last week is I said, right, let's just build a DLL, and then let's build a program in Visual Studio to test that. So if we go to Visual Studio, I now have a Simon Math, and in Simon Math, again, just so my externals can see this, I'll have to add a window capture and Visual Studio so that they can see it. Dev Visual Studio. There we go. Okay, right. So in the Visual Studio, I now have I'll do it that way. So I have a math library, and I copied the math library from the C++. Right now, there are two ways of viewing this. If I go to like 200%. In my DLL that I created, right, what I created the first time round was a DLL that had just a straight function in it, not inside a class, just a global function, just there it is, it's a global, right? The way that Visual Studio prefers you to do your library is using a public class. So you create a class called functions, and within that class you create some static functions, right? So I can then refer to those as static functions from within a class, because this is C++, and you shouldn't just have floating functions hanging around with no class associated with them, right? But you know, I wanted to do both, so I'm just checking that they both work. And yes, so this is the library. Now, some of the things to note here, if this is defined, this math exports is defined. Now remember, I last week I had to go in and I went in and I put a /d and added that define. Now interestingly, when you set up the library in Visual Studio, when you say, oh, I want a DLL library, it immediately adds a #define to the project name, right, the solution name _exports, right? So it automatically adds that, so you don't have to do the /d output thing, which I did because I knew I had to. All that is doing, just so you guys know, is that it's dealing with this DLL, this declare specifications for a DLL export, right? Because when you compile the DLL as a DLL, you have to tell all of the functions that they're supposed to be visible. So they're DLL exports. When you want to include that .h in your program, those are there for import, not for export, right? And so it has to know, am I being compiled as the DLL, or am I being compiled as the usage pattern? So that allows us to include this .h and get it working in both ways with this DLL, right? So there I now have in my function a large class, and it's, well, a large class. It's got a class with 3 static functions in it, so I can refer to them without instantiating the class. And I've got down here 2 just, global functions, just hanging about being global functions, which is not very C++-like, but it is very C-like. And so like last week, what I was able to do is then go into my create a sample test executable, and in there I have my standard main, and I access these math functions, and then I have my cout of math library Simon add, and I can have my math library Simon print. Right now, because they're in the using namespace, right? Because in my DLL I created a namespace called math library. I could have called it something else. It's just a random namespace. So then I can go Control F5, and it will give me something you can't read, but is functional and printing out things according to what it's doing. Now, here to test things, I need to read my console. Right? I don't have an idea of whether things are working or not. I just have to kind of say, oh, should it be 198 there, right? And I don't know if I have to kind of remember, oh, it's B plus B. B is 99, therefore it should be 198. So yeah, that's okay, right? So my test is just kind of, is it there in compiling? It's not a proper actual unit test. Okay. Now you guys have done unit tests. I checked with Evan. You've all done unit tests in JUnit. So you all know about unit tests. Did you guys use Visual Studio and do unit tests in Visual Studio? You've done unit tests in Visual Studio.
I tried once, yeah.
You tried once, but it seemed a bit odd.
Kind of. I was not familiar with the testing frameworks.
Right. So what I did is, in here, I looked at, what does the proper testing framework look in modern C++, right? Because one of the things you'll notice is for things like multi-threading and for a whole bunch of library things, it used to be Boost, right? You used to use Boost with C++ because that's where all the new, interesting, good stuff was in there with handling multi-threading and your timing jobs and things. You'd use Boost on top of C++. With the latest 11, 14, and 17, those have been rolled in. So now the unit testing framework is actually core to C++ rather than being a library that you add on to it. So in C++ 17, you now have up in here where you go to a if you take your solution, and you see now I have got 3 projects within my solution. Right, so, and one of these is a unit test project. And if you go here, you can actually go to add under your solution, and you can add a new project, and under your templates you'll see in Visual C++ way down the bottom here, test. So it's just a standard thing you can now add as a template. You go in and you click in unit test. You can use Google test or the native unit tests. I did the native unit tests rather than Google test, right? Just because that was the one I was using.
What's the difference?
So it's a different library for doing the testing. So I haven't actually played with Google unit tests. So my solution to that question would generally be to go to here and let's see, that's still working, and go, what is the difference between Google tests and native tests? C++. So, why did it take me to Twitter? Okay. I thought I put search the web. Okay. I obviously hit the wrong thing. Okay. Maybe I was Twitter botted or something. No, so here the boots tests. So boost is what it used to be, but now it's become C++ because they've been updating. But that was 2011. It was still in boost. So so comparison of C++ unit testing frameworks. That sounds like a good place to go and have a look. So closed, but answers. I'm going on a it's a hunt. Exploring the test work framework jungle, because basically anytime you're doing unit testing, you're talking about how it deals with mocking functions, how it deals with output, how it deals with grabbing standard output. So can you grab standard output and test it easily? Can you test front-end URLs easily? Can you test web pages easily? So a testing framework will cover different aspects of that in different ways, right? So your standard unit testing framework is, I have a function, I send a function returns a value, I test to see if the value is what I expected it to be, right? That's the simplest unit testing framework. But you know, if I have a printf statement and I want to make sure it's outputting the right thing, that's a side effect of a function. So I can't just push the function and go, what did you return? Because I'm testing a side effect of that function. So now in my testing, I have to go and grab all the output of the program, or the console output for the program, and then hopefully grab that and compare that to see what the side effects are. Right? And in fact, predicting that sort of question was this page of someone who was doing this, which had and you may have noticed this, a nasty combination of cout and printfs, right? So, you know, you're supposed to kind of either do all C++ cout things or all C-like printf statements. Combining the two is a bit rude because it's hard to kind of manage the program. And so what they had is this setup, which was, you know, yay, I can set up an old standard out buffer, and I set that to the redirect buffer, and I then tell cout to redirect the console output, right? So in the setup, I can redirect console output to a string, and then when I ask my program to do something and I expect some console output, I can then look at that console output and say, oh, it should be this, right? So that's great when you're doing, so the setup and teardown says that, so basically why I'm doing this is because I want to be able to store where it should go. The next line here is to redirect it to my buffer that I want to be able to manipulate. And then when I tear down my testing framework, I want to hand it back to standard console, right? I don't want it to be stuck outputting to my file. And that's great, but it doesn't get printf because printf isn't standard cout. It's stream. It's not stream IO. It's standard IO. So the solution was this dirty hack, which I'm sure you can all recognize as being quite a dirty hack, which is you create, you know, a big buffer. So let's just make a big string, and then I fopen. So I reopen, right? So it's taking the file pointer and reopening it with. So the null, I think, is I'm not giving it a name, or I'm not. I think it's the null redirect. I haven't looked into that, but the A is for append, and I'm opening standard out, and then I set buff standard out to go to the huge string buffer, right? And basically what this means is that in the program, when it sees standard out, it now prints it directly to that buffer rather than printing it to the console. Right? So here, so this is one way of hacking my way around how do I get console output. Now in the standard C++ unit testing way, it doesn't have like a drop down that says just capture standard out. So you have to write these sort of things. Right? So as a framework, it doesn't provide you as many things. Whereas other frameworks, grabbing console out is a drop down. You just say grab console out, and it's built into the framework to basically have this hidden behind the scenes. Right? So when they say, you know, exploring the unit test, C++ unit testing jungle, and this was 2010, it's got more things since then. But because so C++ unit, boost test, C++ nano capture unit plus and CXX testing. So because they've brought it in from boost into standard C++, you're more likely to use the standard system now. But basically they're saying, you know, when you're doing evaluating the features, you have to evaluate a feature of any API, any tool you're going to use. So they're suggesting like, what's the amount of work to add a new test? How easy to modify and port? Does it support setup and teardown? So when I was just saying that setup and teardown is, you know, when you start testing, you create a whole framework, and then when you exit, you remove them. And does it handles exceptions well? Has it got assert functionality? Supports different outputs. So if you get to different places, and supports suites. So if you're going to use kind of sub projects and a large number of libraries, can the thing handle those libraries as well? So yeah, so this goes through, you know, an exploring framework of comparing the two. They're just two different frameworks, so they'll have slightly different code bases and slightly different ways of accessing the testing. The one I went with was native. So if I go back to here, yep. So for some reason Firefox really doesn't like being used much, but so I used the native test. I could try a Google test. Shall we do a Google test? And I'll do it sample Google test. And we go OK, so that will be a new testing framework. And so select the project to test. So I'm going to be testing Simon Math because that was my DLL. And it is consumer Google tests as so I've either got tests as a static library or C++ runtime libraries linked dynamically recommended. I'll leave it as it says with the consume the test as a lib. So it creates a lib associated rather than a full DL. Right, and then so this is my test explorer over here that I have in Visual Studio is the native test that I'd written. Here I've got to compile this project and run it, right? So I think this creates a separate test framework outside of the normal test explorer. I'll just check that's true. Aha! So it recognizes test case name. So this test explorer recognizes both the native tests, which is the first one I wrote, and the Google test framework, and combines all of them into my checkbox that it ran all the tests. Right? So I hadn't done that, but apparently the test explorer is happy to use either type. And this, so you see the different syntax here is that this uses test case, test name, and expect equal 1 1 and expect true true. So if you compare that to the unit test approach, the native unit tests, you can see here I create a test class, I define a public method, and that is the name of the test, and then I do an assert, and I have a group of things I could assert. Right? So in this case it's R equal 1 and 1, and here I can also, and it breaks down in R equals because R equal is overloaded with 8 overloads, so quite a lot. And in this case, there is the first one is expected value. The second one, you actually call the function to test it, right? So I could have this add 3 and 2 to give me 5, right? I could have done, you know, should I do math add? I can just write this. I probably should be able to write 3, 2. No, 3 plus 2 rather. 3 plus 2 in there. Right? I should be able to just do math there. So I could just say that these should be the same. Right? This will only case that one case. It doesn't go through a for loop and test multiple times. It just tests that one thing. It uses a tolerance because you can also say, well, you know, if I was using floating point numbers and I didn't want them to necessarily, I don't necessarily know that 2 floating point numbers calculated in the same way will actually be identical. Right? So sometimes if I do a divide, I won't get identical numbers, so I use a tolerance. And then what message I want to send if it fails. And I can also do line info in this one, which tells me which line in my debugging information where this test failed. Right? So I can set up what line of my code was giving me when it failed, where did that call come from? And I can do a print test the same way and kind of print stuff out. Now, the print test isn't actually grabbing the output of the print, so I'm not checking because I'm just checking that it returns the number I expected the function to return. And that's why I started looking at, well, how do you capture the console? Right? And then you have to do a setup and a teardown, and you have to kind of set up your unit testing. Okay, so as you can see, I've added. That was a simple to add a method in the simple Google test, and here you go into simple Google test. The p.h it includes the Google tests, which is where it gets the functionality from, and then in my test CPP I could write a new test just by copying and pasting, and I could do, you know, Simon tests, test name, add, and because I know which of the, because I'm testing this Simon math, I should, and I'm going to check this, so if I do math lime, okay, maybe it's going to make me do the hash and include. Alright, those are just the GTS ones, right? So I'm going to have to. Okay, so to get the .h file in this testing framework, I'm going to have to go to project properties. And in the properties, additional include directories, and edit, and then add, and it's /Simon math / okay, go OK, and then hopefully I should get Simon math.h, right? Because I said go up a directory, go down a directory, find the Simon math directory, and then I should have Simon math, so I should be able to go math library, Simon add. I could do functions and then add, so long, 3, 2 is the same as 5. Now I'm not sure that's going to work because I think it doesn't know where the DLL is, right? But it did know where the DLL is, right? Because when I must have linked it up. So if I have a look at the project properties for the Google test, it will probably be in the linker that it's generated the right. Yeah, there we go. So gtest static libs library natives. So yes, I think it got the additional dependencies, has kind of worked out where the DLL it's testing is. All right, so it set that up for me correctly. So that means that it's got, yeah, this has the appropriate testing, and if I said that was 6, which it shouldn't be, and I go run all tests, so I now get a red, 1 test failed, yay! So now I can code differently. So I could, you know, go into my math library and go, okay, so I've got a failed test, I better change my library and make math add equal that plus 1. That'll be better. So cancel. And now let's rerun all tests. Now, because I've set the test dependent on the library, it'll rebuild the library. And it should have rebuilt the library. Okay, let's... Still failing. A different one fails now. Right? So instead of the Google one fails, my other test add function, which was this 3 plus 2 is 3 plus 2, now fails. Right? So I've got... I can't get them both right. One of them's wrong. Okay, let's fix that then. So, this is the terrible, terrible way of fixing... No, you see, so what I've then got is run all tests. Now all my tests will succeed, even though my code is now horrendously broken. Right? So, when you have failing tests and succeeding tests, it doesn't necessarily mean your code is right. You could have failing tests because your tests are broken, and it could be that from a broken test you fixed your code to be broken, and now your tests are working because they're broken, and your code matches your broken tests. Right? So, just having tests doesn't fix everything. You've still got there are now 2 places where errors occur. Right? The advantage of having 2 places where errors occur is that if you had, 5% of every line you write is an error, the chance of you writing an error in this block that happens to be identical position in this block is now 0.05 times 0.05. Right? So you decreased your chance of getting 2 errors that happen to be in the same place. Right? So I'm less likely to make that mistake multiple times. Okay, so that was... So I thought I'd say, if you go through and you follow either this with writing unit tests, this one was quite nice, this writing unit test for C++ with the Microsoft Unit Testing Framework. You can... it doesn't show you the 2017 version. I did this in 2017, it worked in 2017. This takes you through the whole process as well as developing the DLL and how to create a DLL and how to then use add equals, using R equal. So one of the nice things that the framework gives you, it gives you R equal or R same, which of course are different because equal just means they have the same content. Being the same means they're the same object. Right? So those are different concepts in OO. So you can go through and you just follow that through and it will all nicely work, and you'll have this nice thing here where you've got all these tests, and you can do, when you start thinking, I need to add a new functionality, I write a test for it, the test will then fail, I then go and add the function, the test will then succeed. Right? So it's a way of approaching your development and giving yourself almost like extreme programming, where you have 2 eyes looking at the same piece of code. By making yourself write a test and write the code, you've kind of created in your head 2 different people, one person who wrote a test and one person who wrote code, and the chance they both make the same mistake are lower, is the idea. Right? Doesn't always work, but it's an approach. So I wanted to talk about that. Do you guys have any questions about that? I was surprised that this testing explorer found all things that were called tests and then ran all of them. I thought I might have to have 2 different explorers, but You can write tests any way you like, apparently, and it'll find them here. You can see expect equals, expect true. I don't know what are the expect. So expect any throw, death if supported, debug death. It's pretty negative to start like expect death. So then expect double equal, expect exit, expect false, float, GT. I thought GT is greater than. GE is greater than or equal to, potentially, yes. And this might be just strictly greater than. Has result failed, has result success, less than or equal to, less than, not equal to, near, no fatal failure, no fatal predicate, okay, Pred's format, Pred's throws, through. So, you know, there's a bunch of things you can tell it to expect. Right? And one of the nice things is, you know, you can do things like tell your testing harness, I expect this to throw a divide by 0. Right? So when you give it a divide function, you can tell it that you, rather than having it throw an exception and not catch it, you can have the testing harness go, oh, I'm going to catch that. I know that it's going to do this, so I'm going to say that that's a successful test, that it threw an error. Right? You also have the concept of mocking. So hopefully you guys covered mocking. No, to some degree, yeah. So the idea that you create a mock for what you're going to do. The other thing that I was going to talk about is that we were going to talk about Discord. So Andreas, yes. So you actually sent me the Discord, and I've got the Git repo down, and I see it's in Golang, and so we can skip over to the it's in this one here, there. If I copy that and put it in Firefox. The reason I have to keep going to Firefox for the externals is because Chrome doesn't render to something that OBS recognizes, right? Unless I do capture whole screen, it doesn't let you capture the window. So, but it does let you capture, though it keeps turning it off, Firefox. And turn on Firefox and bring it up to the top. Right, bring it up to the top so they can see it in front of the window capture rate. There we go. Video capture device. There. Oh. Yeah. Right. So now I saw you wrote it in Golang, which is great if you did the cloud course. Did you do the cloud course? Yes. So that made it possible to write Golang potentially, because you guys had to do a bunch of Golang. So what I thought we could do is have you talk a little bit about working with the Discord API. You guys know what the you guys all know Discord, yes? Okay. So Discord has an API that you can start interacting with a Discord server, right? And so what you can do is you can start actually using Discord to do communication and token authentication and those sort of things. It can deal with sending information back and forth and being a chat client for you, right? So you can write your own front ends and your own way of kind of setting up messages and sending and receiving messages. You can also control some of the audio features. So turn audio on and off, mute audio, those sort of things. Now they were looking at the game bridge, which is a tool to connect directly to games. And it appears that they're now actually just going to roll that into the Discord API and not actually have it as a separate API. Andrea, I thought you could potentially talk a little bit about the library and what you were doing. So, and we can have a look at some of the discussion around the code and the approach you're taking. Okay, sound reasonable to you guys? Yep. Okay. So, do you want to come up here and talk against this, or you'll stay there?
Yeah,
or?
I can come up.
Yep.
Do you want to wait after the break?
Yeah, I think we can probably take. We're 53, so we'll take an early break, and we'll come back at 10 past. Give you a 15-minute break. So we'll see you guys at 10 past, and we'll come back and we'll discuss Discord. Okay. Right. So be back in 10.